Alright, so I've given you a new periodic table. You need this periodic table because today we're going to break it down in terms of the four quantum numbers, which was discussed in a lesson that we did while you were gone, but was uploaded to YouTube, and I stress that you should watch it. So, there we're looking at the four quantum numbers. We talked about N, L, M sub L, and M sub S. I told you what each one of these were: the principal quantum number, angular momentum quantum number, magnetic spin quantum number, with a magnetic quantum number, and the spin quantum number. We discussed all of these, and we talked about whether or not a set of numbers could exist. And I'll pick up and run over this really quick because I remember one of y'all had a question about it. In this is the thing. These are set by ranges, by certain sets of rules. N, the principal quantum number, can only be a whole number, and it can only fall between 1 to 7. L, angular momentum quantum number, can only fall within a range of 0 to n minus 1. And those are whole number integers. M sub L, magnetic quantum number, falls in a range of negative L to positive L. And the spin quantum number can only be plus 1/2 or negative 1/2. These are the rules that you'll find yourself following whenever you're trying to figure out if a set of numbers can or cannot exist.
Good morning, Renegades. There are new scholarship applications in the scholarship file cabinet in the counseling office for the Aaron Scott Memorial Scholarship, the Emma Grace McCoy Memorial Scholarship, and the Wolf Foundation Scholarship. These applications and scholarship information has also been sent to every senior in live grades. If you have any questions, please see Mr. Stewart in the counseling office. Seniors are also reminded to complete their FAFSA as soon as possible at www.fafsa.gov. If you need help or assistance completing your FAFSA, please see one of the counselors in the counseling office. Reminder that your FAFSA application and Promise Scholarship application both must be completed to the processing office by March 1st, 2021 to be eligible for the Promise Scholarship. We continue to have a lot of tardies. Please consult your handbook. There will be consequences that will occur that will keep you from having a lot of fun, we hope, this summer or this spring. Evaluations, teachers, if you have not been able to put yours in, I do have some teachers that have tried, and let me know. Please see me today, each one of you individually, so that we can go over whether yours is in or not. Phone use continues to be an issue. There is absolutely no phone use anywhere in this building except in a classroom when the teacher gives you permission to use it. Please refer to your handbook for the consequences. We will take your phones. We will send you home. Driving riding permits. They are in the office. You need to get those today. You are not allowed to drive on school property without that permit being turned in and approved. nor are you allowed to ride with someone onto the school property without a permit being turned in and approved. Bus notes must be turned in first thing in the morning. They must have a phone number on it so that we can verify that that was written by a parent or guardian. Dress code. You are to have no skin from the chin to the tips of your fingers, outstretched by your sides. No, nothing on the head, hoods, hats, caps, unless it is a special day that we have designated. We're going to be celebrating a few people at the Board of Education meeting on Monday, February 1st. Carrie Ann Cook, 2020 West Virginia State High School Golf Tournament 3rd place. The West Virginia Girls Cross Country Coach of the Year is Lacey Bell Stewart. Westside High School had a 95% graduation rate last year. And Thomas Toller is our Poetry Out Loud competition winner. I need to see Miss Carrie Ann Cook and Mr. Thomas Toller in the office after the announcements have been completed. At this time, please stand for the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Have a great Friday.
Okay. So set up 1, 2, 3, 4, 5 set of quantum numbers. In these quantum numbers, determine whether they can or cannot exist. So let's look at this first set. Here's how you start with this. You start with n, principal quantum number. N is 3. Can n be 3? Yes, n can be 3. It falls between 1 and 7. That's a whole number. L. Can L be 3? Why no? What's n? So n is 3. What's 3 minus 1? 2. So L can be 0, 1, or 2. L cannot be 3, therefore this set of numbers cannot exist. Then the second set. N is 4. Can n be 4? Okay, what about L? Can L be 2? Yes. L can be 0, 1, 2, or 3 because n is 4. M sub L, negative 4. Can M sub L be negative 4?
Yes. No.
No, because M sub L goes from negative L to positive L. So it can be negative 2, negative 1, 0, 1, 2 in this case. M sub L cannot be negative 4, so this set of quantum numbers cannot exist.
So if one of them's wrong, the whole thing can't
Exactly.
be right. Okay.
This is only if you are determining if a set of quantum numbers can or cannot exist. This is the difference. Here in a moment, we're going to shift to where you have fixed answers. So look at this third one. N is 2. Can N be 2?
Yeah.
L is 0. Can L be 0?
Yeah.
If L is 0, can M sub L be 0?
Yes.
But spin quantum number, can it be negative 1/2?
Yes.
Therefore, these can't exist. Go here to this fourth set. N is 6. Can N be 6?
Yeah.
L is 5. Can L be 5?
Yeah.
Yes. Because it falls between the range. If N is 6, then 6 minus 1 is 5. So it can be 0, 1, 2, 3, 4, or 5. M sub L is negative 4. Can M sub L be negative 4?
Yes.
Yes. Spin quantum numbers plus 1/2. Can it be plus 1/2?
Yes.
So this set of quantum numbers can't exist. How about the last one? N is 8. Can N be 8?
No.
No. So can this set of quantum numbers exist?
No.
No. That's what you're looking at. Alright, you all give me the orbital notation for the elements. Let's do argon. Top number 18. Give me a minute to give that a shot on your own. Alright, so this is what you should get for the orbital rotation. Remember that we're still dealing with electrons. That's what we're focusing on right now. Our main focus is just on these electrons and where they're at. So every one of these have a fixed representation when it comes to this. Every one of these quantum numbers. So within this, I could choose an electron. And from that electron, you can get the 4 quantum numbers for it.
Destiny Sparks, come to the office. You're signing out.
These 4 quantum numbers is kind of like that zip code like we talked about before. This zip code is like the location, like OCN is 24870. Pineville cannot be 24870 because it cannot live in Oceania. That's not possible. So let's say we look at, and I asked you to give me the 4 quantum numbers for the last electron in the orbital notation of argon. So we look at this right here, because that was our last electron. Stress you, that's not the last electron because it's the last in the end of the chain. That is not why that is the last electron. That is the last electron because that is the last one that we put. Following 100 rule. So in this case, you start very simplistic. Everything is here for you, located right here. So I'm going to make a little window here. And in this, I'm going to start with N, my principal quantum number. The principal quantum number, I told you before, is all based off of and referring to your energy level. In this case, your energy level is right here. 3. So N is 3. Next thing we'll do, we'll look at L. L is right here. I know what you're going to say. Mr. Hall, hold up. That's a letter. That's not a number. Remember back to what we said before when we did those electron configurations. For L, 0, 1, 2, and 3. 0 is S, 1 is P, 2 is D, 3 is F. It's just how it breaks down. So what is L? L has to be 1. Thank you. Now here's where you use a little bit of information. If L is 1, what can M sub L be? What's the range?
1.
1's in it. Remember, M sub L goes from negative L to positive L. So it can be negative 1, 0, positive 1. So there's 3 orientations. How many dashes you got? 3. Each one of those corresponds with this. So this is negative 1, this is 0, and that is 1. So the electron is sitting where? In the 1. So M sub L is 1. And then the spin quantum number. Spin quantum number, if the arrow points up, it's plus 1/2. If the arrow points down, it's negative 1/2. So M sub S is negative 1/2. You have now found 4 quantum numbers for argon and 4 quantum numbers for the last electron in the orbital notation of argon. In this, your periodic table is built for you to do this. And I'm going to show you. This is why I've given you a periodic table. Because what I'm going to break down, I want you to be able to break down. So in this, first thing you need to do, you need to remember S, P, D, and F. These are very special. Here's S block. Here is P block. And remember for this, helium actually sits over here in the S block. You go right here, here's D block. And here is our F block. Every one of these have a fixed representation. So let's say I ask you the question, I want you to find the 4 quantum numbers for an element. I tell you the element. If I look at you and tell you the element, the first number you can tell me is the angular momentum quantum number. The reason is because it's spelled out for you. If it's S block, P block, D block, or F block. If you're in the S block, angular momentum quantum numbers, L is 0. If you're in the P block, angular momentum quantum number is 1. If you're in the D block, angular momentum quantum number is the number 2. And if you're in the F block, angular momentum quantum number is 3. Bless you. So now in this, every one of these have this breakdown. So I'm going to let you get this because I got to erase it so I got room make more sense. Because in this, that's broken down, and now we can work off that number and break down each one of our columns. Perfect example. It's S block. L is 0. What does that mean M sub L is?
0.
0. Because it's the only option. M sub L goes from negative L to positive L. If L is 0, then it's just 0. So guess what column 1 is?
0.
0. Guess what column 2 is?
0.
0. Look at you, Thomas. Which brings me to the last quantum number. The spin quantum number. Remember how we dealt with Hund's rule. First comes the positive spin, which is the up arrow. Then comes the negative spin. So let's say I have the 2s subshell. There's one orbital in there. The first electron goes in, up arrow. First column is the up arrow. So the first column is the plus 1/2. The second one is down, which is the negative 1/2. This is where this information can be coming into play. It's kind of like all these points intersecting the one center location. Everybody got that? I wait.
So does that keep going like that with the plus 1/2 minus 1/2?
No. And I'll show you why. I just need more room to show you why. The S block is like that. The first column is plus 1/2, second column is negative 1/2 because there's only one orbital in there. If there are multiple orbitals, like there is in the P block, D block, and F block, it's the first half and the second half. Good, Sonny? Okay. So let's look here. We're going to focus in on the P block, okay? Focusing in on the P block. If we're looking at the P block, what's L got to be? 1. So what's that mean? M sub L, what's the range for it?
1, 0, -1.
Okay. I'm going to start with the negative 1. I also want you to start with negative 1 because we have to have consistency. So whenever I'm asking this question, but you were right, Spencer. So in this, how many, I got 3 numbers for M sub L. How many columns are in the P block? 6. 3 and 6, 2 times. 13th column, it's negative 1. 14th column, 0. 15th column, 1. You went through it one time. What would happen if we were doing an orbital notation? We would go back and go through those orbitals again. So 16th column, negative 1. 17th, 0. And 18th is 1. This is where the difference is. The spin quantum number changes when we repeat the pattern again. So when we're looking here from negative 1 to 1, this is plus 1/2. And then when we repeat it again, this is negative 1/2. This is where we get the principal quantum number from as well, N. It's like it was before whenever you did electron configurations. Whenever you did those, we dealt with the row. Nothing has changed. The row is still what tells us. 1, 2, 3, 4, 5, 6, and 7. Remember that these two are not 8 and 9, that this also is 6, and this is 7. Because these two actually fit right in there. Whenever you're looking at these, what you will find, the row tells you everything. So, for example, I asked for you to give me the 4 quantum numbers for argon. You have the 4 quantum numbers up there. We did that. That was the last electron in argon's orbital notation. It's the same thing as asking you to find argon. So let's look at argon. Here's what I do. I put X. This is the one I'm trying to find. So this is what we got to remember. So the first number we're going to come up with, let's look at N, for example. You can either do N or L first. I don't care. I normally like to do L first. I'm going to do L first. Argon is in which block? P block. So what does that mean L has to be? 1. Because argon's literally sitting in the P block. N. Here's the thing when it comes to N. When you're looking at N, you're trying to find the energy level. Remember what N was equal to. For our S and our P blocks, N was equal to rho. For D block, N equals rho minus 1. For F block, N equals rho minus 2. In this case, I'm in P block, so what's N equal to?
3.
3, because it's in which row? It's in the P block. Third row, N has to be 3. Because for S and P, N equals rho. Now what about M sub L? This is where breaking down the periodic table comes helpful to you. Because look where argon is. Look over top your column. What's M sub L? 1. And what about the spin quantum number?
-1/2.
-1/2 because it's in the second time that we see the pattern. Bada boom, bada bing. Are they the same? Yes. This is what you're looking at. So there's P block. Everybody got this? Y'all doing okay?
No.
Turkey's okay.
Well, it's good. We're recording, so it'll be on YouTube. If you have a question, just stop me. Alright, so let's look at D block. D block is columns 3 through 12. So we're looking at D block. Since we're looking at D block, what's L?
2.
2. So what's that mean? M sub L. What's the range?
-2, 1, or -1, 0, 1, 2.
So -2, -1, 0, 1, and 2. So guess what we do? Let's break the columns down. So we're going to start column 3, -2. -1, 0, 1, 2. What you went through it the first time, repeat. Column 8, -2, -1, 0, 1, 2. What's the first pattern in terms of the spin quantum number?
1.
Plus 1/2. So columns 3 through 7 is plus 1/2. What about the second one? Negative 1/2 or minus 1/2? On the same pattern we've been doing. So let's say, for example, just for the fun of it, I asked you to give me the 4 quantum numbers for technetium, number 43. So I put an X on the spot.
Hold on.
Okay. While we're having this short intermission, please remember, quiz on Tuesday. Alright, so in this case, remember what I like to start with is L. What's L?
2.
How'd you get 2?
It's the, it's in the block.
D block. It's literally that simple. It's in the D block, so L has to be 2. What about N?
5. Or, no, 4.
It is 4. Here's why it is 4 and not 5. Remember, whenever you're dealing with N and D block, N equals row minus 1. Which row is technetium in? It's in the 5th row, but you have to subtract 1 from the row.
Why do you have to
Yeah, you're gonna have to go back all over that. Just start over that sentence that you just said.
Because
You lost me on that one.
it refers to the energy level. When you're dealing with this and you're looking at the energy level, the S and the P blocks, energy level is equal to the row. But whenever you start breaking it in, the D and F block are not. And they're like this on purpose. Have you guys ever heard of the octet rule? Okay, so the octet rule is literally just a breakdown that atoms want 8 valence electrons. So if you look at it, S orbitals can have 2 electrons, S subshells can have 2 electrons, and P subshells can have 6 electrons. That gives you your 8. But if you break it down here and D was the same energy level, it would make it too great. They're in a lower energy level. So for D, your energy level, which is N, is equal to the row minus 1.
Okay, what's the row that you're talking about? Like, what's that?
First row, second row, third row, fourth row, fifth row, sixth row, and seventh row. It's the rows off the periodic table.
How about I had the wrong square mark? Okay, stop it. Okay, we're good. Good to go.
All right. What about M sub L? What's M sub L?
2.
It's 2. How'd you get 2?
It's, the last number in the, what you call it.
It's the last number in your range. Or very simplistically, Mr. Hall, we broke down the periodic table. So it's 2. About M sub S?
How?
Plus 1/2. There is the 4 quantum numbers for technetium. Questions?
So what does this do?
It tells you the location of the electrons.
But what does it do?
It tells you the location of the electrons.
What is it used in the future?
Yes. We'll use it on Monday.
Past Monday.
Yes.
Past next week.
Yes.
Next month.
Once you learn it, always remember it. Because always fair game.
So the N is what's the number down 5 minus 1 on the.
Yeah, N is that energy level.
Within time just for the second period.
N is that energy level. You're going to find that based off of the rows. So the rows on the periodic table.
And then L is the negative 2 and all those numbers, right?
No. L is the block. S, B, D, or F.
I need to have a tutor in second.
Hey guys, welcome back.